This video is about the Rebuild Assist feature and how to use it in HDDSuperClone. The Rebuild Assist feature set is an optional ATA feature available on some drives. HDST refers to it as Rebuild Assist mode. Seagate refers to it as RAID Rebuild technology. The intended purpose of the feature is to help with the rebuilding of a RAID array with a failing disk. The idea is that it is faster to read data from a disk than it is to rebuild the data from parity. When the Rebuild Assist feature is enabled, a failing disk should perform a quick self-test, and if it finds a bad read element, or as we call it, a bad head, it will mark it. Anytime a read is performed in the bad head, the drive will respond with a predicted error and also the next good sector, or LBA, to read, allowing the software to skip reading data from the bad head. For the RAID, this allows reading the good data and only having to rebuild bad data from parity, thus speeding up the process. Also, when Rebuild Assist is enabled, the drive is supposed to minimize any background processes, although that is vendor specific. HDDSuperClone can now use the Rebuild Assist feature to skip out of the bad head faster. For this demonstration, I have already chosen the project and will now choose Direct HCI mode, as that is the only mode that the Rebuild Assist feature will work with. If you try enabling the Rebuild Assist feature with any of the other modes, you'll get a pop-up error every time you connect that says it's not supported. So I'm going to choose the source drive and destination of null because I'm not trying to actually recover anything right now for this demonstration. Next thing I'm going to do is go into the Tools menu and display Identify Results, because I want to see that Rebuild Assist is supported, and yes, it is supported. Now there's a couple settings that you need to change, and first would be obvious. Go into the Advanced Settings and you enable Rebuild Assist. The second is in Clone Settings, you want to disable Read Bad Head. And the reason for this is that during the Rebuild Assist phase, any predicted errors are marked as bad head in the log. And this allows avoiding trying to read from the bad head during the first round of recovery, so you can focus on the good heads. Also, you want to make sure that the Rebuild Assist phase is still checked. That is normally checked by default. I'm going to shrink the LBA for the demonstration purposes. Okay, now I'm going to connect. I'm going to watch the terminal output. We can see that the Rebuild Assist is enabled. If you understand that, then you understand that, but you don't need to. All you need to see is that head 1 is enabled, or head 0 is enabled. You have heads 0 through 8, so there's 9 total heads. In all actuality, head 8 is some phantom head that never reads any data, so there's really only 8 heads on this drive that are operational. But this says head 1 is disabled. This drive is actually fully healthy, and I'm using the testing feature of Rebuild Assist and telling it to mark head 1 as bad. I've also created some pseudo bad sectors at the beginning of the drive to simulate a small bad spot. Alright, so now I'm going to click Start, and we're going to watch what happens. You can see these skips that are happening were from the bad spot that I had, and you can see right here, Rebuild Assist skip, and this tells you the exact position in LBA that was skipped, starting from this LBA going to that LBA. In the next update in the HD viewer, the next log update, we'll be able to see the big area that was skipped. Alright, you can see the large area that was skipped there. That is the bad head. We'll let this run through. It's going to run all the way through the scraping phase to get the bad sectors that I created at the beginning that are outside of the bad head. I'll show the log after it's all done. Okay, rescue is finished using the current settings. So we can see it hasn't tried to read any data in that bad head, but it did go through the entire trimming, all the phases, all the way through trimming and scraping on the little bad spots that I created. And, we got bad sectors. So what we want to do now to dig in to what is considered the bad read element or the bad head, we go into settings, into the clone settings, and we will enable read bad head. Now, something you will notice, the rebuild assist phase is unchecked. We want it to be unchecked. Now, it unchecked itself after it completed the rebuild assist phase the first time. Now, what I didn't mention before is that the rebuild assist phase, when it is enabled and rebuild assist is enabled in the advanced settings, the rebuild assist phase replaces phase 1. Even though you have it checked here, it replaces it because it goes through a special process. It still performs regular skipping as phase 1 would if it doesn't find a predicted error, but when it finds predicted errors, it uses the rebuild assist to mark them as a bad head. So now we want to read the bad head. We're going to leave that unchecked as by design, and we're going to start again. And this should read relatively quickly because there are actually no bad sectors in the bad head, because as I said before, this is just a perfectly healthy drive that I'm using for testing. Okay, it's finished with that round, and it is as done as can be. You can see that it read all of the bad head. Had this been a real case scenario, you wouldn't expected not to have been anywhere near that lucky, and there would have been a lot of digging going on in the bad head, and you may not have wanted to go extremely far into the process. I would at least recommend going through phase 1 and phase 2 while going in the bad head, just to see if it gets anything, is reading any data in that head or not. How well it works is to be determined by trying it on real case scenarios, and your mileage may vary.